Good afternoon. My name is Ian Nock. I'm here to moderate the second session. So here we have an eclectic mix of presenters who are going to go through and provide their perspectives on their individual levels, much more in the distribution side, and then followed up by a more general discussion from some parties. So probably the best thing to do is just introduce each person in turn. We have Don Robinson, who's here from the Greening of Streaming. We have TimMiller from Plum Consulting. And we have Martin Koehring from Economist Impact Unit. So really, I'm not here to really say that much more than that. I really want to introduce Don first, who's going to step up and give you a very different presentation, I believe.
For the expectation setting in. Yes. Actually, so thank you to Ian and to David and to the IET, Phoebe, everyone for bringing together today. The BBC and the DIMPACT presentations were excellent. I'm going to give you a little potted sort of 10-minute intro to greening of streaming. It's possibly, hopefully, highly complementary to some of the topics that have been mentioned so far today. So it starts with a little bit of a personal background. I've been working with streaming and more specifically content delivery networking since 2000 when I built one of the first CDNs here in the UK. Very focused on live delivery, and that still remains a passion. So today I still run a software company specialised in selling software into the streaming and live content delivery space. Somewhere in that 20-25 year journey, I started writing for a magazine called Streaming Media. And as part of that, in the last few years, I've been chairing and programming the Content Delivery Summit for them, having done similar over here in London for many years. So a lot of history in the CDN space and the content delivery networking space, which is the engineering which gets the streams from the broadcasters to the consumers. As one does when one's wife is away, a couple of springs ago, I watched a film about data centres. And I was quite blown away at quite how much of the Appalachian Mountains were being removed to fuel coal-powered data centres in the eastern seaboard in the States. And I started thinking about some of the infrastructures that I've been involved with and I've been helped to architect and build out. And I started thinking about how much energy was used specifically by streaming in that context. So I first of all wrote an article for Streaming Media magazine called Greening of Streaming and thought the name was quite catchy, so I just spontaneously registered the domain and set up an email catch-all to talk, as I socialised the topic amongst the industry, to catch emails from people who are interested in this issue. So this is late 2017, early 2018, that cycle happened. Over the course of the following CDN conferences, as my chairman's prerogative, I started asking the architects of the big CDNs and the big delivery networks that largely deliver 70-80% of the world's content today, what their sustainability strategies were, what they were doing in terms of engineering around optimizing efficiency in those networks. And they all stared at me blankly and said, I don't know, we normally ask the FD what energy he buys. And that was pretty much the extent of it, if I'm brutally honest. We aren't talking small companies here, we are talking global broadcasters and international operators and so on. It simply wasn't part of the conversation. So as the greening of streaming itself grew to a little bit more critical mass, we propositioned forming something like a trade association. So back in the early 2000s, when my CDN had been one of the first ones here in the UK, we joined the Internet Service Providers Association. I'd become quite interested in internet diplomacy and how trade associations can interface with regulators and policymakers to self-regulate and to present a coherent position for an industry to policymakers and to people interested in various topics. So we propositioned bringing the greening of streaming together, and having also already had a day job, already having a day job, I talked to my colleagues and we set greening of streaming up as a not-for-profit external to my software company. I appointed Adam Cohen, who's sitting in the audience here today, as our exec director, so he can take the brunt of the day-to-day secretariat function and so on, and building members. We invited from DIMPAC, or more specifically from Bristol University and the school around that, we invited Dan Sheen to talk to the industry to start to educate us in the language of climate science in the context of digital media. As engineers, we can talk about caching and network efficiencies and give you all sorts of information in that sort of context till you frankly drop dead in boredom. But the climate scientists have a different language and a different way of understanding this data, and it wasn't familiar to our industry. So we had an initial event, and we brought in some of the big actors who were showing interest, Akamai and Intel in particular. Akamai probably less well known than Intel. They, however, do deliver probably half of all the video streaming you might see, so they are behemoth in our sector. We asked them to present at our inaugural meeting last September, and around that we launched the Greening of Streaming as a members association, and pretty much instantly picked up about 10 members and got together in a sort of organic, chaotic, haphazard way in October and started working out what the members wanted to do and how we wanted to sort of self-govern. I think the interesting thing is the very first cardinal rule of Greening of Streaming is no greenwashing. So for those of you that don't know what greenwashing is, essentially it's using sort of hyperbole in your climate science to market yourself. And we felt that it was important as a group of vendors to self-regulate and to keep a check and balance on each other. So in a sort of club-like mentality, it's a blackballing offence if you greenwash, and that's substantiated by members, which is a way to keep some integrity in the membership badging and your association with Greening of Streaming without too much oversight and accountancy from our own point of view. Being evolved from engineers, we are actually about making a change. We are actually about understanding how you can better distribute live streaming, distribute on-demand streaming, how you can better compress video, how you can do all the technical things and really make a difference. It's not a push things down to scope 3. In some ways, it's often said amongst our group, we are everyone else's scope 3. We're putting our hands up and grabbing hold of that and trying to actually practically make a difference. So we also have a function where we're setting ourselves up to engage with public policy makers. Taking a leaf out of ISPA's book, we are, for example, holding a public event in Parliament, sponsored by the Shadow Energy Secretary over here in the UK, who's been very supportive, to present ourselves as a coherent voice for the streaming industry and the digital media streaming space to policymakers, certainly initially here in the UK, but we have aspirations to do the same in Europe and in US Congress over time. So two different sides to the group. The activities themselves are working group organised. Working group 1 is lovely and esoteric, and it's about learning the language and about developing lexicon and about developing measures and terms that we as an industry agree on that we can make changes to. There's a lot of external influences pointing fingers and saying, we've estimated you're doing this, but we actually know, we do run the computers, we have the physical infrastructure. We're going to put measures in there and try and actually bring that together in a way that's consistent across the members and in a way that when we talk to each other, at least, we understand exactly what we're talking about. So although it's a bit esoteric, that lexicon working group, it's quite an important foundation, and we've taken lots of advice again from organisations like Bristol University on how we might develop that language. Working group 2 is functional outreach, growing the membership base and so on. And working group 3 is probably the long-term aim of what we're doing, which is to share best practice and develop that best practice. But at the moment, we don't even have a needle. We haven't done the science-based measurements. We haven't got there yet. We haven't reached a consensus between ourselves. So working group 4 is very much about that as a practical experiment. It's kind of exploded since December, and we're now already in the process of developing prototype measurement tools across CDNs. We've got some amazing input from Intel and AMD. AMD joined recently, so we're getting very deep insight and instrumentation measurement into the infrastructure itself. And also on top of that, we have Akamai who are opening up their entire infrastructure to us, and we're talking more and more to other clouds and other telcos about becoming members and helping us aggregate this data. We don't want to mark our own homework. We are going to use members' fees to commission organisations outside of Greening of Streaming to help us understand where the needle is. We want to get several of those. To some extent, the data may well just be made open so that we can have any party give us an interpretation. But certainly in the first instance, we want to commission some analysis of these data aggregations so that we can put our finger on our own pulse and have a sense of where the needle is, and then hopefully over the subsequent year, try to get a handle on where that data is and make a change, make a real practical change in the infrastructure. Just to give a final comment, this diagram I did initially as a thought piece, and if I can zoom in on it, which I can't seem to do now, it's really too small, I think, unfortunately. Hold on, let me try one more time. Right, I can't get in there. Anyway, this is a thought piece I did, which is an end-to-end layer 0 to layer 4 picture of a live streaming infrastructure. Now, the set-top box environment and the routing environment that we heard about in presentations earlier is essentially where that orange box is and where the first circle is. There's a lot of distribution amps, there's a lot of splitters, there's a lot of routers and switching and infrastructure. In fact, the top boxes should all be clouds, just to give some idea of how much infrastructure needs to be provisioned to get a live stream from production to a consumer. A lot of organisations think that middle bit is magic. Okay, it's really not. I've put the stuff together physically. It's really not magic, and it uses a lot of power before you even get one stream through. So our expectation from our working group for live event analysis is that actually we won't see any difference between a completely unloaded infrastructure and an infrastructure with 5, 10, 20 million people watching a stream, because these infrastructures are provisioned for peak at the moment. And so it doesn't matter if you've got no streams or 30 million streams going through them, they're still burning an awful lot of power. What we hope is, once we've got that picture, to start turning infrastructure off when it's not used, turning infrastructure off quickly after a live event, and better signalling between organisations. So we're very joined up across organisations. So developing better ways to coordinate these live events, coordinate this infrastructure provisioning, to minimise and become a good energy citizen. We don't know about sustainability. I think what our data output will generate will be translatable to sustainability metrics and so on. But what we can measure is watts, and we're trying to reduce the wattage, but maintain the quality of the streaming. So that's what greening of streaming is about. A little bit of a rattle in 10 minutes. There we go. Thank you.
Excellent. Thanks a lot. Thanks a lot, Dom. Right, so move quickly on then. We're going to go to a slightly different area of delivery of services. We'll move across to TimMiller of Plum Consulting, who's going to come and tell you about their work in this area.
Thanks, Ian. I'll wait for the slides to come up. Just while we're waiting. So my name's Tim. I'm a partner at Plum Consulting. We are a telecoms and media and online consultancy. Economists on one side, engineers on the other, and we sort of meet in the middle. I have been doing work in this area for like 20 years or so, but very little, admittedly, on the environmental side, because as an economist, I like to talk about costs and not emissions. However, one of the things that we've been finding over the last few months, especially talking about things that we've heard about earlier today, is actually there's a lot of parallel between the way that costs are incurred and the way that emissions are felt. We've always talked about kind of fixed costs and variable costs. We heard earlier about fixed emissions and variable emissions in terms of economies of scale and so on. So actually it's a really interesting parallel for us to think about. I think hopefully this will work, yes. We were commissioned by the UK Spectrum Policy Forum, which is a group that sits within Tech UK that advises DCMS and other government bodies in the UK on issues to do with spectrum. Obviously, the clue's in the name. And one of the questions that they had was about, is there an issue in the way that spectrum is being awarded in the UK and around the world? That is leading to greater than needed carbon emissions. So what we wanted to do was to think about, how does spectrum policy at all affect climate change? Is there anything it does that's good, anything it does that's bad? What should the government be doing to try and make sure that it's sitting within the government's overall net zero targets? What should they be doing about the way that they deal with spectrum? To start with, this was inspired by something that the Radio Spectrum Policy Group, the RSPG, did, looking at spectrum policy and climate change. And there was a big submission from the GSMA, which is the industry association, the Global Industry Association of Mobile Operators. They put in kind of 10 points about how governments around the world should change their spectrum policy to make sure that emissions were reduced. Now, coincidentally, each one of those 10 points was very good for the mobile industry. Just how happened. So we want to look at those, but we want to think about things in a bit more of a holistic way, because spectrum is not just used by mobile. And I'm sure that people in the room here and watching online know for all that there are lots of things that spectrum is used for, some of which mobile wants to use that spectrum as well, and you sort of have to balance that a bit. So what did we want to do? And I kind of put out here now that this study is available online. I'm not going to go through everything in detail. If you're interested, then please do go and download it from the Spectrum Policy Forum website, Tech UK. There is a link on our website as well, but I think it goes straight to their website because they paid for it. We wanted to think, first of all, about how do we get to climate change? You know, what in the telecoms industry as a whole affects climate change. And the reason we did this was because we started off thinking about spectrum policy and climate change and found that nobody had thought about it so far. There was just basically no research. So we started to think about ICT generally. How does telecoms, media, and so on, impact on climate change? And we thought about this actually in a number of ways and found that, I'll go into it in a bit more detail soon, but it's both good and bad, because there are good bits where we are able to use telecoms instead of travelling. We are able to use telecoms to collaborate better and make things more efficient. That is a good thing from the environmental point of view, because it means that we're cutting down emissions. But it's also bad because doing this means that we are burning energy to actually get the telecoms working. So telecoms is both an enabler and a polluter, which is great, apart from the fact that nobody's actually measuring any of this. We heard earlier about people not monitoring, not measuring what the issues are. So we really needed to kind of understand how, going forward, people could actually start to look at that. On the other side, I'll come back to that in a moment, but on the other side, there is this question about spectrum policy. How does spectrum policy then feed into that? And having identified how telecoms overall feeds into climate change, we were then able to think about spectrum policy generally and spectrum policy changing the way that people use telecoms. And we'll go through some of that in more detail. As I said, there was a load of literature on the first of these, and that was the easy part of our job. The second part was less easy. And I'd love to be able to say that we came up with a lovely number of minus 10% if we did this, but actually it's impossible to do, partially because things aren't measured in the first place, and secondly because we couldn't identify any specific impacts. So the first of these, I've mentioned this briefly, but let's just talk about the way that the communication sector has an impact on climate change. And I want to be really clear, we're not just talking about telecoms here, we're talking about broadcasting, we're talking about amateur radio, we're talking about the energy sector using spectrum. And if you look at Ofcom's list of who uses spectrum, then every single one of those has an impact on climate change. We do concentrate on telecoms a lot because that obviously is a massive industry and a big user of spectrum. But the real danger is that with them making the most noise, then you start to allocate more spectrum to them, taking away from other people who might actually have a significant impact. And that includes the people like the energy industry. The energy industry rely on some kind of either dedicated spectrum or dedicated networks using other people's spectrum to get up-to-date, accurate, constantly evolving information on energy use, so they can make sure that it's being provided in the most efficient way, and they can plan going forwards how it's going to be delivered and produced. There's a massive danger, and I went and spoke to the Joint Radio Company, which is a group of UK energy companies, about what they need to use spectrum for, and their concern is that all their spectrum is going to be taken away and given to mobile because mobile shouts a bit louder than they do. But they're really concerned that that's going to inhibit the way that they can actually monitor stuff. It's also very important for science services. Science services, things like radio astronomy is not necessarily something that has a direct impact on climate change in the UK now, but it does change the way that we can kind of research and understand the science of climate going forward as well. So it's very important that we actually understand that the spectrum is used by many different people. Now on the other side, as I said, it's a polluter. And it's very interesting hearing earlier about how the biggest part of the pollution comes at the end user side, where it's the home routers and the devices. Because actually that's something that we identified, that it's the handsets, it's the mobile networks on the access side that is much more important than the core side. People are talking all the time about reducing the need for microwave backlinks, backhaul links for mobile networks, because you can use fibre and it's much more efficient. But actually, that is such a minuscule part of the problem. It's about the access networks and making sure that they are as efficient as possible. The mobile networks do have a role to play on the core side. I mean, I'm not saying that you shouldn't do stuff if you can. But there's a lot more around the use of green energy and so on that they can do. We also looked at fixed networks. We looked at broadcasting. We looked at the way that, and if I say broadcasting, is television and radio. And we looked at kind of amateur and so on as well, just to see if there was anything important there. But we found this kind of this very interesting point around the fact that it's both positive and negative for climate change. And we really need to get the positives working better and get rid of the negatives. So what we then did was, as I said, we looked at lots of literature and found virtually nothing on the second part, but lots on the first part. So we decided to go and talk to people, and we talked to people all around the industries, and the steering board at the SPF, and just looking at the way that people had responded to public consultations on related areas and so on. And we came up with a list of policy options. These are things that theoretically governments around the world could do to try and make sure that they are reducing climate change, reducing emissions as much as possible, because our focus was very much on emissions rather than, as we talked about earlier, the kind of production of equipment and so on, although we do talk about that as well. We came up with a list of policy options. It's very focused at the UK, but actually we've already gone and spoken to the French regulator about this. We've got interest from the Portuguese regulator about this. It's actually quite applicable across the world. And our policy options are on a lovely table, which is a little bit confusing because we've got stuff that moves across different places. We categorised them in a few different ways. So first of all, we thought about the way that spectrum is awarded. So who do you give it to? The second point, and that's the purple. The second point is around, if you do give people spectrum, then what must they do with it? And then the third point, which is the orange, which kind of feeds into the pink a bit, is not what must they do with it, but how can you incentivize people to use spectrum in a more efficient way? Because there are some things you just can't regulate for. As I said, I'm not going to go through each of these in detail, but I think it's very interesting to talk about some of these, because there is some stuff here that basically people don't really talk about. The first of them is, number one up there, is spectrum for 5G. Now, spectrum for 5G is ongoing in the UK, making sure people have enough spectrum to make sure that their networks are running efficiently. And it's not just about the amount of spectrum, it's about where the spectrum is in the bands. So making sure that you have enough lower frequency spectrum so that you don't have to have too many base stations in place, but making sure that you have enough higher frequency spectrum as well so that you have sufficient capacity to enable people to actually make use of their devices without having to have really high power on their devices to communicate. And the reason that that's important, and it's important kind of across the entire industry, is because so many things are looking at using 5G technologies in addition to kind of the traditional ones. And making sure you've got enough bandwidth there to cover things like kind of meter monitoring and so on is really key. But then, as well as the amount of spectrum, you have to think about the way it's allocated. Historically in the UK, we had a problem in that bits of spectrum were given to different operators, and there were bits all over the place. That's largely been resolved now. It's more difficult in other countries.
but it's more costly in terms of energy use to have non-contiguous spectrum. So kind of trying to make sure everything is a bit neater actually helps on that point. And again, that's not just for mobile, but also for different types of broadcasting and so on. And then 3 and 4, I think I've mentioned them already, but it's a really key thing that people sort of get, this sort of gets lost in a lot of the arguments, that you need to have spectrum for other services, science services, energy services. Making sure that that's available and that they have the right sort of spectrum means that you can go down the monitoring route and you can make sure that you are being much more efficient than you otherwise would be. So who you give spectrum to is a really important thing. But then how those people use the spectrum is also important. And there has been a lot of work done over the last couple of decades about how to make sure you incentivize people to use their spectrum in an economically efficient way. Yeah, and this is a really key point I'll come back to in a minute. You've got to make sure you use the spectrum in an economically efficient way. We award it using an auction to make sure the people who are going to get the greatest economic benefit from it get to the spectrum. You make sure that you overcome any market failures by putting coverage obligations on so that people must cover 99% of the population. You make sure that people are only allowed to use certain power limits in areas because you're worried about RF radiation and so on. All of this stuff kind of comes from an economic point of view. And this is fine, but there's a trade-off there, because if you are coming at it from an economic point of view, you're not thinking about the environmental impact. This also comes down to the incentivizing options part. People are not penalised for holding spectrum that they've held for years and years and years. The mobile operators have all the spectrum they use for 2G, still running 2G networks. Still running 3G networks. We've got a point here about switching off legacy networks. And everyone, whenever I say this, people think, oh, 2G, 3G, when's that going to be turned off? I want to throw a bit of a bomb in the room and say, yes, that's DTT. That's FM radio. That's anything that could be switched off. And this is a long-term issue. Yeah? This is not something that we want to do next year, but we need to think, is it actually efficient to be running terrestrial TV in the future? I won't talk about other things in detail because I've got limited time, I know. So what are our recommendations? Now, this is a really important point. I was talking about the fact that we look everything in terms of economic and economic costs and making sure that everything is done efficiently under that. And indeed, if you look at Ofcom's duties in terms of awarding spectrum, they have 2 big duties. It's not phased exactly like this, but they have to make sure that spectrum is being awarded in an economically efficient way, and they have to make sure it's being awarded in a socially efficient way to kind of maximise social welfare. They do not have to make sure it's awarded in an environmentally efficient way. And in fact, if they take account of environmental impact when they're awarding spectrum, they are going against their duties and they are acting against their charter. So that has to change. And this is not restricted to Ofcom, because we found a really interesting report from the National Audit Office pointing that out. This applies to Ofwat for the water industry and Ofgem for the energy industry as well. They do not have to, and in fact they are not allowed to take account of environmental impacts when making policy decisions. So first thing, that needs to change. The second thing is that, as we've said a couple of times today, there isn't a monitoring and measurement regime in place, and there needs to be. And that needs to be run by a regulator. It needs to be run by a third party. And when I say a regulator, I'm not necessarily talking about Ofcom, but it needs to be a third party who does it. So those are 2 kind of big things. And then after that, we got a list of the things from the previous slides, which we've ranked in order of which have the biggest impact and which are the shortest and easiest to implement. The first thing is actually, it's a really important thing around protecting the science spectrum, but it's really easy to do because you just maintain the current level, but it must be done. And then we have kind of a list of others here, and I won't go into each of those because I've talked about most of those already. And that's what we came up with as our recommendations for the industry to take to DCMS and to take to Ofcom. And that's where I'd like to finish. So I hope that that's useful, and I look forward to any questions on that later. Ian.
Thank you very much, Tim. We'll come back to the controversial comment later, I'm sure, in the questions regarding DTT. But then I'd like to introduce you now to Martin Koehring from the Economist Impact organisation. So please come along and tell us a little bit more.
Thanks a lot, Ian. Thanks a lot, everyone. I'm very excited to be here with you today. So, I was really fascinated to learn from Dom about, the kind of streaming, greener streaming, and also from Tim about spectrum policy and climate change. I hadn't really thought about those things. And, what I'm going to talk about is the kind of the broader context. We have done a study at Economist Impact, so just by way of introduction. So I lead the World Ocean Initiative at Economist Impact, as well as I'm a senior manager for the Sustainability, Climate Change and Natural Resources practice that we have at Economist Impact. We've only recently formed Economist Impact, which is a really exciting development in the Economist Group. Obviously, we produce the Economist newspaper. We do a lot of other things. We have our own events. Actually, this week is the Sustainability Week at Economist Impact, and we also have a consulting business. We have a thought leadership business. We produce like indexes from food sustainability to electric vehicles and so on, and this is all now consolidated under Economist Impact. And as part of Economist Impact, we produced this study on sustainable disruption, the 12 decarbonizing technologies for cities. So in a way, this is kind of the broader context of what we are seeing in terms of technology. There hasn't really been a study that combines these elements. There's been a lot of focus on decarbonization, there's been a focus on technology, and there's been a focus on cities. So bringing all this together is quite unique. And we were commissioned by Osborne Clarke, the law firm, to look into that. So just in terms of the background for the study, and then the technology itself, and then the city policy. So that's the kind of the structure. So in terms of background, so obviously this is such an important topic, if we look at decarbonization, and particularly in cities. Because we looked at, can look at decarbonization in a broader sense, but cities really account for 2/3 of the world's energy, so it's really crucial to look at decarbonization in the context of cities. And also, they account for more than 70% of global CO2 emissions, so the focus on cities made sense. And obviously with more than, at the moment, about 70% of the global population expected to live in urban areas. By 2050 is really, I think at the moment it's about 2/3, but it's rising and rising. So the global population will be living in urban areas, more and more. And so hence we focused on cities, we focused on decarbonization, we focused on the latest technologies that work in cities. So we looked at 12, actually we had a long list of 26, and we honed in on 12 because these have impact, as well as are scalable, as well as are investable, but they are not necessarily the best technologies, but they're technologies that have an interesting story to tell, and they could be applied now that, where, we could see an acceleration in decarbonization if we focus on these technologies more and more. They have opportunities to create jobs, they can lower costs, they can improve quality of life, and we looked at 10 cities in the world as a kind of a sample for this study. Just in terms of the approach, so we had a literature review that looked at all the different decarbonization trends in cities. Then we did a data audit. We convened an advisory board, as we tend to do in our research projects, and then we did the data collection and analysis. And we did this for these 10 cities. So London is part of that, but we also looked in Europe, Barcelona, for example, Paris, Berlin, and Florence. So kind of a spread there in terms of cities in Europe, but we also looked at New York and San Francisco in the US, and in Asia we looked at Delhi, Seoul, and Singapore. So we looked at the applicability of these technologies in those cities. And the sectors we looked at, so first of all, we looked at building and construction, and this is such an important part of the equation because, if you just look at the latest data, the United Nations Environment Programme looked at buildings and construction. They're responsible for over 36% of global energy consumed, and as much as 40% of energy-related CO2 emissions. So looking at buildings and construction is such an important component of this topic. Knowing that more than half of the population lives in cities means that the energy consumption of cities has a disproportionate impact on CO2 emissions. So making these technologies and infrastructure making sure that these kind of run smoothly is really important for decarbonization. So we looked at mega cities as well as smaller towns. Transportation is such an important aspect, so that's why we looked at that's why we looked at transportation as well, and looking at, for example, electric mobility, encouraging walking, cycling, and so on. These can cut emissions significantly as well. So that's why we looked at building and construction, city infrastructure, including energy and transportation. So then if you look at the criteria that we applied, so we had three main criteria, and we looked at impact. It's such an important, mention how important impact is, not just in terms of the economic impact, but also the social and environmental impact. So the impact here we measured by looking at, how well does this technology function in comparison to traditional alternatives. Then we looked at whether there is evidence showing that this technology helps to reduce carbon emissions. And if yes, by how much is this technology expected to reduce greenhouse gas emissions? And then we looked at whether there's evidence that the technology offers an additional benefit beyond cutting emissions. So we also looked at economic and social benefits. And then is there evidence that the technology can kind of cause harm as well? Because that's also one of the things, as we just heard from Tim as well, there can be positive as well as negative consequences of introducing technologies. We look at scalability. As scalability, we mean to what extent this technology is currently developed, and then how high are the initial investment costs by governments and individuals, and what is the technology's ease of integration into a city based on additional infrastructure required, in addition to the technology itself. And then we looked at investment, and this is such an important part. Anything we do at Economist Impact, you need to take into account the investment potential, both private and public. So we looked at what is the total equity funding amount for these kind of technologies, so producing technology, what is the total number of investment firms and individual investors interested, because that also shows that maybe the volume of investment isn't that large, but there are a lot of investors now interested in this technology, and what are the national, regional, and city regulations that support technology investment, R&D, and so on in this technology. So these are the criteria, and here they are, the 12. Drum roll. So then we have them here. So we looked at these 12, and you can see which ones are doing really well. If you look at the red, it's very high scalability, for example, for high efficiency heat pumps, low carbon and concrete alternatives, very high scalability. But some of them still have kind of low investment potential. You will be able to see that the investment column in particular is kind of not doing as well as the others, which just shows that maybe governments and individual investors haven't really grasped the investment potential for these technologies. These are not necessarily the top 12, as I mentioned, but they received high or very high scores for the indicators. You can actually look at all of the 26 that we scored on our website, impact.economist.com/sustainability. Everything, including the spreadsheet with all of the data, is freely available. So now let's look at each of those individual sectors. So for buildings and construction, let's highlight some examples here. So for example, digital twins. Digital twins are a virtual replica of a building that monitors and mirrors performance in real time. And this is such an exciting development now. It only received a medium score in the impact and scalability categories. They do outperform, for example, building automation systems, but they require substantial amounts of energy to operate. So again, similar to a lot of technologies, they have benefits, but they also have costs. And in this case, there's a lot of energy required. They also require additional infrastructure. The technology shines in one of the investment indicators. So the current level of investment is $1.2 billion US. It's quite high, but there are only few investors that are interested in this. It's a relatively novel technology, but has lots of potential. This is really an emerging technology. There are, as I mentioned, few investors. Current private sector investors are already willing to provide large financial contributions here. Let's look at another one in the buildings and construction space. So we have high efficiency heat pumps. They have the potential to reduce greenhouse gas emissions significantly. They could reduce energy for heating by up to 50%, emitting less CO2 than other heating methods. The technology is heavily promoted through government support, but it lacks private sector support at the moment. We looked at these 10 cities. All cities except Paris and Delhi have policies that support the implementation of high-efficiency heat pumps. As you know, in London, we have the domestic renewable heat incentive now that encourage households to use renewable energy to heat their homes as part of these ongoing strategies to reduce greenhouse gas emissions. And through this domestic renewable heat incentive, households that install eligible heating systems, like those kind of high efficiency heat pumps, can receive a quarterly payment for 7 years, subject to adherence to the scheme's rules. So there is that investment and that opportunity. Let's look at city infrastructure. And here, we can look at smart grids, for example, smart grids and smart meters. And here we can see that the implementation is estimated to lead to a 12% reduction in energy and greenhouse gas emissions, and provides a very high number of potential benefits. The benefits include a more efficient transmission of electricity, faster restoration of electricity after power disturbances, reduced operation and management costs for utilities, and that means ultimately lower power costs for consumers, reduced peak demand, which also helps lower electricity rates, and also increased integration of large-scale renewable energy systems, which then, of course, reduces CO2 emissions of the electricity grid. So clear benefits here. It scores, as you can see, high on all fronts: impact, scalability, and investment. And this is, of course, coupled with this support from government, also private sector investors that have called attention to the importance of the need for greater integration of this technology. In Delhi, for example, the Ministry of Power has a national smart grid mission that enables smart grid projects to, providing funding for up to 30% of projects' costs. So this is an exciting opportunity. Unified communications, as we all know, very important. Voice over Internet Protocol is part of that. It's, of course, as everyone knows, has this kind of unexpected technology that has these benefits in terms of city decarbonization. During the pandemic, it has highlighted the environmental impact that unified communications can have. Millions of people carried on working and going to school from home, significantly reducing greenhouse gas emissions associated with travel. And of course, this technology will continue to be important post-pandemic. There is, of course, the opportunity for the hybrid working models, as we know, a positive impact on emissions, of course, as well as quality of life for many people. It can reduce CO2 emissions between 2020 and 2050 by up to 4 gigatons of CO2, huge potential. It scores high in scalability because these technologies are broadly available and already are being implemented in most places as a result of the pandemic. So huge opportunities here. If we look at transportation, and as we know, transportation also is such an important part of decarbonization, let's focus on mobility as a service. Using a phone or a web app, mobility as a service integrates across different modes of public and private transport. With additional newer mobility services, ride sharing, for example, e-scooters, that allows users to travel door to door with a single interface. So huge opportunity here. Potential security risks. We needed to kind of look at the whole impact. So obviously there are security risks, significant logistical and technical challenges as well. Developing these and implementing these systems. This obviously has an impact on the technology score for this category. It's obviously an emerging technology. It's got high in scalability. It's available to implement across all the countries we looked at. Relatively low costs, opportunities to leverage as well, existing transport infrastructure. Private investment is high, $2.3 billion already, but it hasn't really received the public and government investment that could really help to scale this technology. So on the investment side, it only receives a medium score. And then we have vehicle-to-grid technologies, or V2G, and often used in combination with electric vehicles. They enable kind of energy stored in charged car batteries to be used as an energy supply source at times of high demand, supporting grid balancing. So we have, in addition to the benefits offered from switching from traditional to electric vehicles, there's also the opportunity kind of optimizing these V2G technologies, and these could actually enable a reduction in greenhouse gas emissions by 24%. So huge opportunity in this space, often overlooked. Currently, V2G technologies are more or less in the pilot stage in most of the cities in the study. Some implementation is occurring in France, Spain, Korea, also the UK and the US. So there is lots of opportunities to develop this more. And as you can see, it only receives a low investment score despite its high potential. And then just finally, in terms of city policies, we have a couple of best practices here. We just did a case study on Warsaw as well. Have a look on the website. We looked at, for example, in New York, the Smart City Challenge funded cities across the US to create an integrated smart transportation system using data, applications, digital technology to help achieve efficient and low-carbon mobility. It leveraged over $350 million in public and private funds to support kind of innovative ideas such as mobility as a service projects. So this is one example of a recent best practice. And then we have Barcelona. The EU has actually mandated 80% of smart meter uptake by 2020. Spain has been a leader in smart meter proliferation. Almost 100% of homes implement some form of smart meters in Barcelona. That's very impressive. And then we have Seoul in South Korea, and they have a pilot scheme to incentivize zero energy building development, and they subsidize 80% of the cost of installing building automation systems. There are many more best practice examples in the study. As I mentioned, have a look at impact.economist.com/sustainability. All of the data is freely available. And happy to answer any questions. Thank you very much. Thank you.
Thank you, Martin. So this comes where we get to the questions, and I've actually got some questions here that come from Martin's presentation more than anything else, and that is that I'm an engineer. I'm predisposed to see problems, to then identify how to solve the problem, how to optimize that problem. We generally tend to optimize the biggest issues that are in any particular scenario. We try to look at how to have the best return on our time and investment. So the question really for you, Martin, is media and telecoms was notably absent from many of the focus areas from your presentation. So where does media and telecoms come in the scale of return on investment, basically, for effort?
In a way, it is represented through the unified communications. Mm-hmm. So there is, I mean, as I mentioned, actually the potential post-pandemic for unified communications is enormous. And often it is not really as appreciated as it should be as a decarbonization technology. So in addition to all of the benefits in terms of hybrid working, more flexibility, in terms of needing to do this, it's actually a great decarbonization technology as well. And there's a lot of media and communications element in all of these technologies. If you look at the need to spread the word about these technologies. So, for example, the fact that the technology that I just mentioned, we have the V2G technology, for example, is very much under communicated. There's a little awareness that these technologies have great impact. So I think the media industry as a whole has a role to play in communicating about the need for decarbonization, the potential that these technologies have.
Okay. So to take it more from actually Tim's presentation, there's a lot of enablers in what we're doing rather than necessarily being polluters, mm-hmm. in terms of the scale of return.
That's right, yeah.
And Tim, your thoughts on that, because you've talked about that in your presentation. What are your thoughts now after seeing Martin's?
I think I'd agree. I mean, I think that when you look at the list of 12 and also the list of 26 that you see afterwards, a lot of the benefits from that come from increased communication. I mean, it's all the technologies. There's a huge list of technologies there which are required to get the best out of environmental impact. So it's reduced environmental impact. And a lot of that comes down to technology use and making sure that communications is in place. I mean, in order for V2G to work, you actually need to know how much energy is being used in the network and whether you actually need to get energy flowing in a certain direction. And all of that comes down to making sure the communications are there. So absolutely, I'd agree with that.
Okay. So the other point that also came from this was looking at the overall holistic view of energy usage, of decarbonisation, etc. And again, there is still going to be some challenges with the telecom side, media telecom side in doing those enablers, and it's still got an impact on the market. In your presentation, Martin, you also concentrate on financial value associated with it. Do you have thoughts on any other motivators?
Yeah, so there's definitely the economic, but also the social element. And when we looked at impact, and that also came through in your presentations as well, is that often the whole sustainability spectrum isn't looked at. It's either focusing on the economics, focusing on the social element, or too much focus on the environmental element, but actually looking at impact from economic, social, and environmental perspective is really important. And that's what we try to integrate into the impact equation. So for example, mobility as a service, another actually technology that has a media and communications component, does really well, but it's also a way of creating new opportunities, creating new jobs, creating new ways of lowering distances and these kind of things. But it also has a cost. It has a cost because it potentially also kills jobs. It creates jobs as well as kills jobs. And that is often something that we need to take into account. It has benefits for certain people and has costs for other people.
Okay. And Tim, in your presentation, you touched on the way the regulators aren't themselves motivated to actually drive the motivation in companies to do better jobs with regard to the environment. How do you see that changing then, other than just changing the basis of their engagement? Is there anything else that we can do?
I think following on from what Martin just said, there's a kind of question about what people are willing to do. Mm-hmm. We can sit here, we can talk about all the things that we could do to try and make sure that we are making less of an environmental impact. And there was a question earlier about, should we move back to terrestrial? And I'm going to sit here and I'm going to look like I've got something in it for terrestrial. But the thing is that, yes, sure, terrestrial may have a lower economic impact kind of per person or overall, but it also has less functionality. And it's going to be very difficult to get people to accept that they should watch more live TV on terrestrial if they are used to watching it on demand, or they want to be able to interact with it, or whatever. So you have to sort of come at it from ensuring that what you are doing to make sure that you reduce your environmental impact does not impact on people's utility. Yeah. So we talk about the kind of the social impact of all these policies, and this is actually a relatively recent thing for regulators to think about how does this impact on the social welfare of people. You're now going to have to say, well as that social welfare, you sort of have to keep that the same and try and keep the economic side efficient as well, but at the same time, just make sure it's not bad for the environment. So it's not an easy task.
It's not about how to stop people doing things, it's about how to enable them to do it more effectively and sustainably.
Exactly.
Okay. And from that then, it comes down to, in that new era, that new way of consuming content, streaming that we've now been doing for the last 10, 15 years. Dom.
25 years.
Yeah, you described a very complicated network that we couldn't see on the.
I'm sorry about the diagram.
Yeah, no, we couldn't even see that. And
happy to share it
that's
afterwards.
just a model.
Yeah,
as well.
absolutely.
And so where's the big bang per buck to get an impact in reducing the impact of streaming, considering consumers want it, considering the utilities, what they're after? How do we make it more effective?
I can give you some sort of broad brush, sweeping engineering suggestions that may well not work economically. IP Multicast is the one that stands out above all in live streaming. IP Multicast is the greatest technology that never was, because there's a lot of people making a lot of money out of inefficiency, and that cannibalizes making things more efficient quite often cannibalizes quite a nice revenue generator for people, and that's a big challenge. IP Multicast sort of stands above all in my mind, in my space, as a key thing. I think beyond that, it's a conversation. Actually touching on the policy and on the regulatory side of thing. I think part of it's a conversation with the consumer about what's good enough, not exceeding good enough unnecessarily. The nice thing about IP technologies is you generally can provision an exceedingly good service on an on-demand basis, so not on-demand video, but on if I want to watch a 32K UHD 4,000 frames a second high-quality video, because that's my thing, you can actually deliver that for single users. But the question is, when you're dealing with a mass market where you put the sort of median line for the good enough services, and so you don't constantly cache stuff deep in expensive caching, energy expensive caching environments, when only a couple of people are really using it purely to put it on your marketing and say, we now support this. And if you manage expectations with audiences to say, well, if you want the ultra service, you might have to wait 4 seconds. But if you want the sort of median service, you can click and watch it. And understanding that conversation with the consumer isn't something I think we've had enough conversation and developed enough feedback. So a real sort of candidate for that. One of the groups we've been talking to with Greening and Streaming has been talking about green button services as part of their streaming mission. So if you are extremely energy conscious in your consumption, click the green button and we'll try to get the message back down the delivery chain to just give you the less than premium quality service, but something that you're happy with because it's maybe 30 times, 50 times more energy efficient through the circuit and so on. And so there's a conversation to be had with the consumer as much as making decisions as engineers and the economics. You know, as I mentioned, IP Multicast is the way to make live streaming more efficient, but it's going to put a bunch of people who deliver the inefficient way out of business, and we have that complex challenge.
And is there a balance in that technology investment to get that if consumption is moving more away from live? For general
I don't know
content.
that consumption is moving more away from live, actually. I think actually, certainly in the streaming world, live having a massive explosion at the moment. The availability and immediacy of live sources has proliferated and is driving live as a technology. You know, you have to think beyond just linear TV and think about all the live streaming applications that are being delivered, all of the different conferencing tools that are emerging and so on. Actually, live would probably dwarfs on-demand content, but the internet, for legacy reasons, evolved and is still talked of as an on-demand environment. But I've never worked with on-demand video, and I've worked with streaming for 25 years. I have worked with it, but it's more of an adjunct.
Yes. Okay.
Yeah.
Do we have some questions from the wider audience out there in the...
So I'll start with a question from Josephine Harris, and apologies if I paraphrase it a bit. I think she's essentially asking, what about the other sustainable development goals? Because we've talked a lot about climate, but there are also other goals around ecological limits, social and environmental inclusion. I might combine that with a question of my own and say, if you're trying to optimise 27 things, I think there are 27 sustainable development goals, does that mean you really have to generalise the models that we've seen from Martin and from Tim and from Glyn into actually quite a sophisticated bit of software that tells you, when you're designing or updating a service, what you need to do to try and maintain compatibility with all those goals?
If I go first on that, I mean, I think that it's a very valid point, and as I mentioned, there's been a trade-off in the past for regulators between economic efficiency and social welfare maximisation. If you're then trying to actually maximise or optimise things over 27 different goals, it's going to be really difficult to do. And so you do need to have some sort of prioritisation in the way you're thinking about it. I don't think it's my place to sit here and say what that should be, but it's a conversation that needs to be had, and I think that's really what we came to as a recommendation, that it's a conversation that needs to be had. And obviously we've been doing stuff in providing communications to kind of developing countries and kind of remote locations and so on for years now. Not personally, but enabling it for kind of regulators in developing countries and so on. So we know about that sort of stuff, but we've never really thought about the environmental impact before. And as I said, you don't want to take away that digital inclusion work by saying, well, actually, it's going to have a massive environmental impact, so let's not do it. You just want to try and make sure you do it in the way that is most efficient.
Thanks.
Yeah, and I just wanted to add to that as well that, one thing that we want to make sure in the impact rating is that there are no unintended consequences, that we don't just focus on reducing emissions, but that we are not suddenly creating health risks, for example, like digital twins, for example. There are security risks associated with it. There are environmental benefits, but security risks. You need to balance that. But I would say across those SDGs, there are actually lots of synergies. Like, for example, we're talking a lot about sustainable consumption. There's actually an SDG on cities as well. There is an SDG on decent work. What we want to make sure is that as we work towards decarbonization, we create high-quality jobs. And we create them also that we don't create new poverty. And that is also one of the SDGs. So creating synergies between the SDGs and making sure there are no unintended consequences as we focus on decarbonization is really important.
Thanks.
Can I just chip in on the unintended consequences? Something that's complex specifically within the streaming strata, without commenting on the sort of wider economic and social issues. A really nice model for the engineers who perhaps tuned into the IET. Data attribution has become a very established reference so far for how to try to apportion ownership of internet services. I have a lot of questions. I have a lot of my own personal doubts. It's not a greening or streaming thing. It's my own personal doubts about the validity of that, because I think it's very important to measure the power required to make infrastructure available before you even send a stream. And if you measure just the stream, it's kind of back to Glyn's point about the router. The router's on 24/7, but if you only watch an hour of Netflix, then Netflix only... Well, actually, if the router wasn't on, Netflix couldn't deliver a service. So there has to be some... we have to address that ownership of the shared infrastructure somehow, and it's a really complicated challenge. But with data attribution as a sort of historical way of referencing these efficiencies, if you simply make the efficiency in one part of the value chain, you can actually have a really adverse effect further down the chain. So companies working in our sector in isolation tend to think, oh, I can give you a higher video compression. Therefore, it's less data that can be attributed to data attribution, so it must be greener. So automatically the codec is marketed as a greener codec. The problem is when you then go and transcode the back catalogue of the BBC or the iPlayer's historic long-tail content and burn several terawatt hours of energy converting your back catalogue, and nobody ever watches that, that's a completely false strategy in terms of any green energy. So transcoding stuff on demand when it's actually required, or at least doing the first transcode and making sure that can loop back into the system, is a different strategy. But pre-transcoding it just because it's in theory going to be greener further down the line is a false economy on both probably financially and certainly in terms of energy efficiency and so on. So
I think that also comes down to the fact that when we use the word optimization, we're using it in a very engineering-like way. Yeah. Optimization does not mean maximum minimizing. It means actually determining a solution that's optimum based on all inputs and all outputs.
Yes, and I was really pleased to see such a heavy focus on the corporate impact, the operation around the digital media objective. One company with two people running it and delivering, a YouTube scale business is completely different to another company with 3,000 executives who are all flying around to all the conferences and so on, and yet delivering essentially the same service. One has a clearly much larger carbon footprint or much larger sustainability challenge ahead of it.
Okay. Any more from the online?
Yeah, I've got one from Graham Turner, who's a previous chair of this network. So
my predecessor.
His question in. He's asking, there's a push by telcos and companies like Google to get IoT devices into the home. Is there an opportunity to leverage that? He didn't use the word leverage, actually. I shouldn't put that word into his mouth. It's a terrible word. Is there opportunities to use that capability to improve energy efficiencies in homes?
Who wants to go for that one?
Yes. There's a very specific thing, actually. I don't know how many people are tuning in, but if I had one ask of the industry at the moment, I'd ask smart meters to be included in computer power supplies. Because at the moment, it's actually impossible from an IT level to read the system you're using, the power demand of the system you're using, without plugging a meter in between the plug and the wall, because we've got no visibility of what's going on in the power supply. So if there was an industry pressure group, I personally would like to see at the moment, it's to force PSU manufacturers to give the IT system or the owner of the system the ability to say, how much energy am I using? Because at the moment, we're blind.
So you basically, it's not real-time optimization, but you want to instrument the network so you can make better decisions.
There is a disconnect between energy and IT, and it sits across the power supply. In the data center, you've got top of rack, which you often have that infrastructure management read on But on individual computers, you might know what your chipset's using, but you've got no idea as an aggregate what the whole computer's using. So we're completely blind. It's all finger in the air at the moment, other than measuring the total input to the data center. So that would be my ask.
I mean, it's not just computers, though. I mean, it's basically everything in the household that uses energy. Yeah. There's a massive push to everyone having a smart meter and understanding what their energy use is. And they say, oh, yes, you can save so much energy by having a smart meter. But actually, if you look at the smart meter, it doesn't tell you what is using that energy. It just says, you've used this much energy, and here it's used during this time of the day. And so actually, having something that's a bit more disaggregated or discrete forms of energy is actually going to be helping to reduce that as well. Yeah.
So it's about being able to use it, because at the end of the day, we all talk about smart meters. Actually, pretty much they're all dumb. The only thing that's smart about them is sometimes we don't need someone to come and read it.
Yeah.
Which is a bit like the models we're all using as well, that we have models where some of them are based on empirical data, some of them are based on guesswork. And we're optimizing those models as well.
And the thing is that there are things that can be done going forwards, and it's things like the power networks can understand when there are peaks in demand and when there are troughs, and try and make sure that things are being used in the troughs where it can. And that comes down to, again, having more equipment put in that will turn things on at the right time. Mm-hmm. But it comes again down to having the proper measurements and monitoring systems in place, which currently they just don't have.
Mm-hmm. I would like to probably finish off with one question to each of you, and it's probably the big God question, the question that you just want to throw in there and see what you think, and that is, what would you, if you had one thing you could do, what would it be to improve sustainability? One thing. Dom.
I think you've got to take the input side of it out, because obviously if we can take the energy input, and that's obviously got to be a priority, is decarbonise the inputs. On the output, I think getting some better visibility, by my last point really, obligating power supply vendors of any IT technology to give us some visibility of the power would be a good start, because then we'll know what we're doing. So that would be my request.
Tim?
I was trying to think if there's anything other than what I put as my kind of first recommendation.
Obviously, you had lots there. You've got to look for one. What's your big thing?
I think the big thing is making sure that the people who are making the decisions, so whether it be regulators or governments, do actually have an obligation to think about environmental impact when they're doing it, because currently they don't.
And Martin?
For me, it would be bridging that gap between investment and impact, because currently, if you could see that in the table produced, that there's lots of impact, positive impact, lots of scalability, opportunity, but the investment isn't there. So, and that is both public and private, and often it's either or. It's either the government going in and then private investors kind of having a wait-and-see attitude, or private investors really going in, like, for example, with autonomous vehicles and these kind of things, but then, government's not really on board. So bridging that gap between impact and investment, that's really crucial.
Okay, excellent. Well, I've only got one thing left to do, that's to hand over back to David, because you've been very instrumental in putting this together. So how would you like to end?
Well, I'd just like to thank everyone for coming. Thank you to all our speakers, and thank you to those who are watching online. I mean, I think what we've been trying to do here is to share knowledge. I mean, one of the things we noticed is that the people on the delegate list are quite senior, and that's good. But we want to see this cascade down. So we want to see. So I was thinking, like 20 years ago, or maybe if you talk to software engineers about, say, non-functional aspects of their software, like security or reliability, you might have a difficult conversation, but it's now embedded in the culture. That engineers just know they have to make things. They have to make them economic, obviously. They have to make them secure. They have to make them reliable. They have to make them maintainable. And we need to, as an industry, both within the broadcast industry as a wider industry, find ways that we embed that culture so that it's second nature to people to make things sustainable. And I think with that, I'll close the conference. Thank you very much, everyone. Thank you.
Thank you very much.